So, are we alone out there? It's probably the biggest question we've ever asked ourselves. Today, we're jumping headfirst into the absolutely thrilling and, well, often fatal search for life on other worlds. And to guide us, we're going to follow the adventures of an interstellar explorer named Chase and see just how dangerous this whole thing can be.
Right, so our story kicks off with a planet called K2-18b. It's an exoplanet about 124 light years away, and it's shown some of the most promising signs of life we have ever seen. And our explorer, Chase, he seems pretty pumped about it. I mean, volcanoes, alien life, beaches, sounds like a vacation, right? What could possibly go wrong?
Well, first start, there's the travel time. Even if we used our fastest spacecraft ever, the Parker Solar Probe, it would still take almost 200,000 years to get to K2-18b. Yeah, not exactly a quick trip. This mind-boggling distance is really the first massive hurdle we face in the search for anything out there. And that insane distance brings up a huge question. I mean, there are billions, and I mean billions, of planets just in our galaxy. With that many to choose from, where do you even begin looking for another Earth? How do scientists possibly narrow it down? Okay, so it all starts with this idea, the habitable zone. You can think of it as the Goldilocks zone around a star. Not too hot, not too cold, but just right. It's the sweet spot where a planet could have liquid water on its surface. And as far as we know, where you find liquid water, you've got a shot at finding life. But here's the catch, and it's a big one. A planet can be in the perfect spot and still be an absolute death trap. A great example is Proxima Centauri b, the closest exoplanet to us. It's in the habitable zone, but its star is a volatile red dwarf that just pummels it with deadly radiation. We're talking solar flares that would strip away any atmosphere and basically sterilize the entire surface. So if we can't actually go there, because, the whole 200,000-year trip is a bit of a deal breaker, how do we study these promising worlds from so far away? Well, scientists have figured out a really clever way to investigate them right from here on Earth.
They use incredible tools like the James Webb Space Telescope and a technique called transmission spectroscopy. It sounds complicated, but the idea is brilliant. You wait for a planet to pass in front of its star. As the starlight shines through the planet's atmosphere, different gases in that atmosphere absorb very specific colors of light. By looking at which colors are missing, we can figure out exactly what gases are there. It's like reading a chemical barcode from light years away.
And this ability to spy on alien atmospheres leads to a really deep, kind of unsettling question. With all these billions of potentially habitable planets in a universe that's billions of years old, where is everybody? Why is it so quiet out there? This is the heart of the Fermi paradox. It was first asked by the physicist Enrico Fermi back in the 1950s. And it's just this simple, powerful contradiction between how likely alien life seems to be and the fact that we found, well, nothing. Just silence.
And the possible answers to this paradox are wild. Maybe space is just too big to travel across. Or maybe we're just cosmic babies who've only been listening for a tiny blip of time, like 60 years. Some people think advanced aliens are watching us, like we're an exhibit in a galactic zoo. Or, a little darker, maybe they're hiding. But the most sobering thought? Maybe they all wiped themselves out.
This idea is called the Great Filter Theory. It suggests that there's some evolutionary step or challenge that is so incredibly difficult to overcome that almost no civilization ever makes it past. And the really scary part is, we don't know if that filter is behind us or if it's still waiting for us in our future. The very technology that lets us reach for the stars might also be what dooms us. So, given this great silence, most scientists aren't really looking for little green men anymore. Instead, the search has shifted to something much more fundamental. They're looking for the chemical traces that any kind of life, simple or complex, might leave behind in a planet's air. These chemical traces are called biosignatures. A perfect example is right here on Earth. The huge amount of oxygen in our atmosphere is a dead giveaway that life is here. It's constantly being pumped out by plants and microbes. So scientists are hunting for similar chemical fingerprints on distant worlds. And that brings us back to our case file, K2-18b. Scientists looked at its atmosphere. They found methane, which is interesting, but it can be made by geology or life, so it's a maybe. They didn't find any free oxygen. But, and this is the book one, they did find dimethyl sulfide. Here on Earth, as far as we know, that gas is only produced by living things, specifically marine life like phytoplankton.
That is one of the most exciting hints of biology we have ever found.
So, yeah, the first aliens we find probably won't be waving hello. It's much more likely to be microbial life, invisible to us, but so widespread that it's literally changing the chemistry of its entire planet. K218b could be a water world, completely covered in an ocean that's just swarming with microscopic aliens. But let's pretend for a second. What if we could get there? What would it actually be like to step foot on one of these promising new worlds? Well, as our explorer Chase is about to show us, the term Earth-like might just be the most dangerous phrase in the galaxy. Okay, first up, Proxima Centauri b. Even if you found a nice spot between the scorching hot side and the frozen dark side, its red dwarf star could unleash a solar flare at any moment. You'd be fried by a blast of lethal radiation in an instant. Game over. Next up, Kepler 22b. This one's a beautiful super-Earth that could have a planet-wide ocean. Sounds lovely, right? Wrong. The surface gravity is more than double Earth's. Every single step would feel like you're carrying another person on your back. You'd collapse from sheer exhaustion in no time. And we're back to our top candidate, K2-18b. The atmosphere here is 3 times thicker than Earth's. If you were foolish enough to take your helmet off, the sheer weight of the air would crush you. We're talking immediate catastrophic barotrauma. Your lungs would just collapse.
How about a trip to Kepler 186f? The forecast might call for rain, but this is supercooled rain. It's water that's still liquid even though it's below freezing. The second it touches anything solid, like your spacesuit, it crystallizes instantly, trapping you in a tomb of ice that's growing by the second.
But hey, let's say you survive the environment on K2-18b. The life there could be just as deadly. You take one breath of unfiltered air and suddenly, unknown alien microbes are in your system. To them, you're not an explorer, you're lunch. And for our last stop, let's visit Trappist-1b. This poor planet orbits so close to its star that gravity is constantly squeezing and stretching it like a stress ball. This tidal heating makes the whole world volcanically unstable. You could be vaporized by a random, massive eruption at any moment. Chase's many horrible deaths are a funny but pretty stark reminder of a basic truth. Space is actively trying to kill you. The universe was not made for us, and even the most habitable planets are packed with dangers we can't even imagine. And all of this whole journey of cosmic discovery and spectacular failure, it really forces us to look back at our own planet. If finding a safe place out there is this hard, and surviving on it is basically impossible, what does that tell us about the one we already have? It suggests that our world isn't just home. It's a miracle. An almost impossible miracle.